Hello student, welcome and very good morning to you. Today I will be discussing the easy solutions of Irodov numericals 38, 39, 40 and 41. This solution will be extremely helpful for the preparation of NEET, main and advanced. And it gives a clear concept on relative motion and kinematics. Like and share the video and comment on it, because this comment will be extremely helpful for me to make the next video for you. Question number 38. A point moves with deceleration along the circle of radius r so that at any moment of time its tangential and normal accelerations are equal in moduli. That is, here given condition is dv by dt. This equal to, this is the v square by r. At initial moment t equal to 0, the velocity of the point equals to v naught. That is, when t equal to 0, v equal to v naught. No problem. And here acceleration w equal to, this is the minus dv by dt. Okay, no problem. Question number 1, the velocity at the point is a function of time and is a function of distance. So we have to express, v equal to function of t, and v is the function of distance covered. Okay, no problem. And finally, the total acceleration of the point is a function of velocity and distance. And finally, we have to calculate total acceleration W equal to, this is the W2 tangential acceleration square plus this is the normal acceleration square. Okay. Now look at this. So here minus dv by dt, this equal to, this is the v square by r. Therefore, look at this. This is the minus dv by v square. This equals to, this is the dt by r. No problem. Now integrating, look at this here, v to the power minus 2 into dv. This equal to, this is the minus integration dt divided by r. Okay, no problem. Now look at this. When t equal to 0, v equal to v naught. When t equal to t, suppose velocity is v. So look at this, from here you can write v to the power minus 2 plus 1 divided by, this is the minus 2 plus 1, limit of integration from v naught to, this is the v. And here look at this is the minus t by r. No problem, this is the. Therefore, from this relation you can write 1 by v minus 1 by v naught. This equals to, this is the t by r. Therefore, 1 by v, this equals to, this is the 1 by v naught plus t by r. Now, what is the LCM? Look at this. LCM is the, this is the v naught into r, and r plus v naught into t. Therefore, v equal to, look at this. This is the v naught r divided by, this is the r plus, this is the v naught into t. So look at this. This is the required expression of velocity in terms of time. Okay, no problem. Now velocity in terms of distance. Look at this, minus acceleration. That is, this is the minus v dv by ds. This is equal to, this is the v square by r. No problem. Therefore, look at this here. This is the dv by v. This equal to, this is the ds by r. No problem. This is the negative side. Now integrating, look at this here, dv by v. This equal to, this is the minus 1 by r. Integration ds. Now what is the limit of integration? When s0, velocity v naught. When distance s, velocity is v. So look at this here. ln, this is the v by v naught. This equal to, this is the minus s by r. Therefore, v equal to, this is the v naught into e to the power minus s by r is the required expression of velocity in terms of distance. Okay. Now, total acceleration w. You know, the normal acceleration, this is equal to v square by r. Look at this here, v equal to v naught to the v naught into e to the power s by r. So look at this. This is the v naught square into e to the power minus 2s by r divided by r. No problem. And this is the omega t. Look at this. This is the magnitude of omega n. So total acceleration, this is the root 2 times of, this is the omega n. Okay. Because these two are right, these two are perpendicular to each other and magnitude equal. So total acceleration is the root 2 times of normal acceleration. That is, the acceleration is the root 2 into, this is the v naught square by r into e to the power, this is the 2s by r. Okay, no problem. Now question number 39. A point moves along the arc of a circle of radius r. Its velocity depends on the distance covered s, as v equal to, look at this here, v equal to a into root under s. Where a is constant, find the angle between the vector of total acceleration and the vector velocity as a function of s. Suppose this is the circular path. A particle moves, a point moves along the circular path. We have to look at this. This is the normal acceleration omega n. This is the direction of velocity, and this is also the direction of tangential acceleration omega t. Tangential acceleration wt, and this is the velocity vector. So net acceleration is directed w along this direction. Now we have to calculate the angle between v and total acceleration. Okay. Now look at this. Here v equals to a root s. Therefore, from here v square equal to, this is the a square into s. No problem. Therefore, the normal acceleration wn, this is the v square by r. So look at this. This is the a square into, this is the s by r. Now, what is the tangential acceleration? Look at this. This is the Wt. This is the V into dV by ds. So, look at this here. Now, differentiating this with respect to s, we get, look at this. This is the ddt of dds of, this is the dds of Vs. This equal to a square into s. Therefore, look at this. This is the 2V into dv by ds, this equal to, this is the a square into 1. Therefore, v into dv by ds, this equal to, this is the a square by 2. This is the tangential acceleration. Now we have to calculate the angle between tangential acceleration wt and total acceleration w. So look at this here, tan phi is equal to, this is the normal acceleration Wn divided by tangential acceleration, this is the W2. Now look at the W tangential acceleration Wt. Now what is the normal acceleration? Look at this normal acceleration, this is the a square s divided by r. What is the tangential acceleration? Look at this. This is the a square by 2. So look at this and this cancel out. Therefore, phi equal to, this is the tan inverse, this is the 2s by r, is the angle between velocity vector and total acceleration vector. Okay. Now question number 40. A particle moves along the arc of a circle of radius r according to the law L equal to A sine omega t. So look at this, L equals to, this is the A sine omega t. Okay. Where L is the displacement from the initial position measured along the arc. And A and omega are constant, R given, A given, omega also given. Find magnitude of total acceleration of the particle at L equal to 0 and L equal to plus minus a. Look at this when L equal to 0. Look at this here t equal to 0. Okay, when L equal to this is the a. Look at this here sine omega t. Look at this here sine omega t. This equal to 1. Therefore, omega t this equal to pi by 2. Therefore, t equal to this is the pi by 2 omega. Here omega given, omega is equal to 2. So, t equal to this is the pi by 4. Okay, no problem. Now, we have to calculate the total acceleration. First of all, this is the tangential acceleration. Tangential acceleration. Now, first of all, tangential acceleration. Now, differentiating this expression, this is the dl by dt, this equal to v. So, this is the a omega, this is the cos omega t. Now, this is the dv by dt. Now, dv by dt, this is the a into omega square sine omega t, that is the negative side. So, tangential acceleration W2 is the negative value. Okay. Now, look at this. Here A is equal to, this is the 0.8. Omega is equal to, this is the 2. So, this is the 4. Okay. And this is the sine omega t. So, look at this here. This is the 3.2 sine omega t. Now, when t equal to 0, this is the omega t, this is the wt. When, look at this, when t equal to 0, look at this, the tangential acceleration is 0. When t equal to pi by 4, look at this, when t equal to pi by 4, this is the tangential acceleration, this is the 3.2 sine omega is 2. So, this is the sine 2 into pi by 4, that is the pi by 2, that is 1. So, tangential acceleration here, this is the 3.2. Now, normal acceleration Wn, this is the v square by r, no problem. Look at this, here v is equal to, this is the a square, v equal to a omega cos omega t. Therefore, look at this here a square omega square, this is the cos square omega t divided by, look at this is the r. Okay, when t equal to 0, look at this, when t equal to 0, here omega n, this equal to, this is the a square omega square by r. What is a? A is equal to, this is the 0.8. So, a square equal to 0.64 and omega is 2. So, this is the 4. Look at this is the 0.64 into 4 divided by r. What is the r? R is equal to 1. So, at t equal to 0, the tangential, the normal acceleration is, this is the 4 and this is the 2.64. Okay, meter per second square. When t equal to, look at this, pi by 4, look at this, from this expression, you can easily calculate omega n is equal to 0. Okay, so total acceleration, look at this, so total acceleration at t equal to 0, this is the, so total acceleration at t equal to 0, this is the 2.64 meter per second square, and total acceleration at t equal to pi by 4, look at this is the 0. So, this is the 3.2 meter per second square. No problem. Now, question number 41. A point moves in the plane, so that tangential acceleration, this is the Wt, this equal to A. And its normal acceleration, this is the Wn, this is the Bt to the power 4. No problem. Where A and B are the positive constant and t is the time. At the moment t equal to 0, the point was at rest. That is when t equal to 0, v is also 0. Okay. Find how the curvature radius r of the point of trajectory. Total acceleration w depends on distance s covered. So first of all, we have to calculate distance s. Look at this. This is a tangential acceleration W2 WT. This is the dV by dt. So dV by dt is equal to A. Therefore, dV equal to this is the A dt. Now integrating 0 to t, and this is the 0 to v. Therefore, look at this here, v equal to A. Now displacement, look at this. This is the ds by dt. This equal to this is the at. Therefore, s equals to this is the half a t square. No problem. Now the normal acceleration wn. This is the v square by r. What is v square? Look at this. V is equal to this is the at. So look at this. This is the a square t square by r. Now, t square is equal to this is now t square equal to 2s by a. So look at this. This is the a square into 2s by this is the a into r. Therefore, this is the 2as by r. Therefore, total acceleration W, this is the tangential acceleration square plus normal acceleration square. That is the 4 a square by r square. So look at this a into this is the root under of 1 plus 4a square by r square. Now we have to calculate the radius of curvature. Look at this here v square by r. Look at this here v square by r. This is equal to this is the v t to the power 4. Now what is v square? Look at this. V square is equal to a square t square. So look at this here a square t square by r. This equals to b t to the power 4. So look at this here r is equal to this is the a square by b into t square. Now what is the value of t square from here? Here t square is equal to this is the 2s by a. So look at this. This is the a square divided by b, and this is the 2s by a. So look at this a cube divided by this is the 2bs is the radius of curvature of the point. Radius of curvature of the trajectory. Okay. Many thanks for watching this video. This video will be extremely helpful for your preparation in JEE Main and Advanced. Thank you.